Hey YouTube, welcome back. In the previous video, we did talk about why it is important for WhatsApp to use WebSocket instead of HTTP. Today, we will talk about the real-time message delivery and how actually the message delivery indicators work. If this is your first video, welcome to the channel. We talk about system design and data structure. In this video, it's I guess video number 4 or 3. I actually lost count of our series that we're trying to design WhatsApp. In our first video, we went through the high level design. After that, we did talk about the schema design, and today we will talk about how actually the message is delivered, okay, and how the real time message delivery actually works. So we agreed in the last video that we're trying to use WebSockets because it's a bi-directional communication. It will provide low latency. It has less overhead than HTTP requests. So we have here example user A and user B, and both of them established a WebSocket connection between server A and server B. So when a user, for example, opens the chat app, it will initiate a WebSocket connection with one of the chat servers, as you can see here. This persistent connection will remains open throughout the chat session, enabling the real-time communication that we talked about all the time. Okay, so once user A and user B is connected, when user A here try to send a message to user B, the message will travel through user A's WebSocket connection to the server A or any server that user A is connected to. So it will go through the server A. Server A then will looks up the user connection cache to determine whether user B is online, and if it is online, or if is user B online, in which server currently users B connections is. Okay, so let's say that user B is online. So when user B is online, and again, server A will know from the user cache connection if user B is online or not. Let's say that user B is online. User B is online, so server A will forward the message to server B, which delivers the message to user B with our web socket protocol. Because it's a bidirectional communication, the server can send the message or the request or the data to the client without the client sends a request for it. If user B is offline, the server A will send the message to the notification service, which triggers a push notification to notify user B of the new message. How this will look? It will look something exactly like that. Whenever when user BA find that the client is offline, it will sends the server it will send a message to the notification service, which will trigger a push notification to notify user B or the client of the new message. Okay, so right now we know how actually the message delivers. We need to understand how actually the WebSockets or the message delivery status is happening, or how the message delivery indicator is actually working. So again, as we said before, WebSockets enables a real-time status update for messages, providing users with instant feedback on messages status. We have three status. We have message sent, we have delivered, and we have read. Okay, how this will happen? So when let's say that the client wants to send a message to client 2, this client. I guess this might be complicated. I guess here it will be easier for you guys to see it. Let's delete everything. Yeah, this will be way more easier. So when user A sends a message, it is transmitted over their WebSocket connection to the server handling their connection, which here is server A. Whenever the server A received the message, it pushes it to the message queue, this message queue that you have seen in our high level design, and it will send an acknowledgement back to user A that the message is sent. Like upon receiving this acknowledgement, user A app updates the message status to send. If user A is offline when attempting to send the message won't be sent until they are back online. The message remains in pending status of on users A device. Okay, so again, the client or user A will try to want to send the message to user B. When it sends the message to the server will send it to the message queue. Okay, the message queue will update it will send it to a message servers, or update it or send it directly to server A or whatever it will be. And once actually it's sent to the message queue, it will be has the status sent. Right now we need to understand how actually the message delivered actually works, how the status of message delivered actually work. Once user B received the message, it sends an acknowledgement to server B. So basically the server B sends a delivery acknowledgement to server A, and server A sends the message status delivered to the message queue for for permanent storage, and then relies this update to users A app, which reflects the message as delivered. And if user B is offline, server A will not receive an acknowledgement of delivery from server A. So the message will remains in the sent status for user A until user B reconnects. When user B becomes online, the client app sends the update to server B, at which point it sends a delivered acknowledgement to server A. User A's app is then updated to reflect the delivered status. Okay, so again, when the message hit user B, it will be had the delivered status. The status of Fred, it's even simpler. Basically, when user B opens the chat window and views the message, their app will send a read acknowledgement to server B, and server B logs this event in the message queue and forwards the read status to the server A. Server A will push these updates to user's A's device, allowing user A's app to display the message has read. So you can see two writes, but they are in blue instead of red here. So yeah, this is how actually the deliver status is happening. This is actually how the message delivery actually working. So that's it for this video. It was a quick video as well, and see you in the future, guys.